Welcome back to part 2 of Chapter 1, Section 3's notes. I figured we'd start with something that isn't actually in the notes, but a lot of students in most of the semesters I teach this class could always use a little more assistance with the types of sampling and what it means to take a sample using a specific method given a scenario. So that's what we're going to start with today. And it actually has to do, well, not really, but kind of, with this. The U.S. population. So this is at the Census Bureau's website. There's a population clock. There's actually one of these in the U.S. Census Bureau's headquarters in Suitland, Maryland. It's in one of the hallways in the building where I used to work, and it just continuously counts up. And sometimes I would just stare at it for a while. I don't know. I guess I'm kind of a nerd. Oh, let me move myself a little bit so you can see what goes into this. So, according to this clock, and this is just an estimate, obviously the US or world populations aren't increasing at a constant rate like this. But approximately in the US, there's a birth every 8 seconds, a death every 12 seconds, one international net migrant, so people are coming into the country, people are leaving the country. We are netting an additional person into the country every 47 seconds, which means every 16 seconds on average, the US population is increasing by 1. And we're currently approximately, again, there hasn't been an actual census of the United States since 10 years ago, so this is just an estimate, but we are supposedly just over 330 million people in the United States. And I use this little widget here. I selected the date that this is being filmed, August 8th, 10 years ago. And the US population on that date was estimated to be under 310 million. So just in the last 10 years, over 20 million people, new people, are in this country. That's wild. What's even more wild is the world population. Holy cow, how much has it increased since I started talking? Wow, crazy. Interesting. So anyway, the US population is about 330 million people, and that's a fact we're going to use to create some samples. So let's say, I'm going to move myself back down to the corner. I like being in the bottom. Okay. You need to survey 1,000 people in the United States to ask them how they rate their happiness on a scale from 1 to 10. And we're going to use the fact that there are about 330 million people in the US. So, how would you create your sample of 1,000 people using each of these techniques? So, you should be able to get a sample of 1,000 people in the United States using a simple random sample, stratified sampling, systematic sampling, cluster sampling, and convenience sampling. What I want you to do is take a few minutes and sketch out, maybe on a blank piece of paper somewhere, or if you are just writing on lined paper, just put that as the next thing in your notes. I think this is good practice. How would you construct these samples? And go into some detail. For a simple random sample, what is it you need to do? For a stratified or cluster sample, how are you breaking up the population? I'm not asking for an essay. Your responses should only be like maybe 2 or 3 sentences, perhaps. But take a few minutes, go through those, see what you come up with. Come back when you're ready, and I'll discuss what I came up with. All right, you ready? Let's see here. I wrote these in invisible ink, so here we go. For a simple random sample, what I would do is I'd have to assign everyone in the United States a number from 1 to 330 million. So for a simple random sample, you have to number the population. Now, I'm not saying that this is going to be easy to do. I'm not saying you even have a list of all the people in the United States. I don't know if anyone has that. But this is how you would do it if you had to. And I know people have social security numbers already, but those are kind of like not sequential. I don't think they're sequential. So numbering them this way would probably be best. Once we numbered everyone, we would use a random number generator to produce 1,000 unique 9-digit numbers in our range from 1 to 330 million. So these numbers would represent the 1,000 people we will sample. Okay, and it's not talking about how we would actually go out and do it. We're not talking about the entire 7-step process from the last video, but just in general. How would we take a simple random sample, number the population, know what values you're looking for, and then use a random number generator to produce those numbers. We would ignore repeats. We wouldn't want to sample the same person twice, all that good fun stuff. So that would be a simple random sample. And it's kind of absurd to suggest that you could do this. Assigning everyone in the US a number from 1 to 330 million, that's a fantasy. That's never going to happen. So you can see how difficult some of these sampling methods are for really large populations. All right, for a stratified sample, let's see here. Remember, for a stratified sample, you have to break the population into groups, or strata. So we can divide the United States into the 50 states. Seems pretty natural. We can take a simple random sample from each state. So there are many ways that you could take a stratified random sample. I'm doing it by state. You don't have to do it by state. You could do it by some other characteristic. You could do it by people's age or what region of the country they live in. It doesn't have to be state. And I'm taking a simple random sample of 20 people from each state, but I realize that could be problematic because we're taking 20 people from North Dakota or Idaho and 20 people from New York and California, even though New York and California have many more people. So you could take the same sample size from each state, or you could sample proportionally based on state populations. Again, there's not just one way of doing this. And if you decide to divide the US into different strata, then that's fine. But the idea here is you divide the population into some kind of groups, and you take a simple random sample from each group. That's the idea of stratified sampling. All right, systematic. I don't think this one's going to be very reasonable either, but we can say how it would be done. All right, so what I have here is we would, again, start by assigning everyone in the US a number from 1 to 330 million. Now, the example that we originally went through where like all of Anderson High School was at a pep assembly and in the same place, that's not going to work here because as amusing as it might be, I don't think there's any way to get everyone in the US in the same place at the same time. So we're just going to have have a list of all the people in the United States and then use a random number generator. We would start at a random value between 1 and 330,000 and sample every 330,000th person in that list. That could be a way that we do systematic sampling. It's not going to be reasonable to get everyone in the same place, so we'll just list everyone and go every 330,000th person in order. All right, cluster sampling. Remember, for larger populations, cluster sampling tends to be one of the easier, more reasonable ways to sample. So let's see here. We could divide the US into households. Now, households are very small clusters. They only have like anywhere from 1 to, 10, 15 people at the very most. I don't know, if you've got like multi-generational homes, there could be a lot of people in there. Why are the clusters so small? Why did I choose them to be so small? Couldn't we just use states again as our clusters? Well, remember, for cluster sampling, you divide the population into your clusters, you sample the clusters, and then if a cluster is in your sample, you sample every individual in the cluster. If we did states, we would be taking an SRS of states, and then if a state was sampled, we'd have to sample everyone in the state. We only need 1,000 people. There are way more than 1,000 people in each state, so the clusters would have to be smaller. So we're zooming in. Not just a state. Cities, I think, are also too big because almost every city is going to have over 1,000 people. Even if you do like an entire block of a street like we did in the last video for that example. I think even that, a street block could have hundreds of people in it, potentially, if you've got some like apartment buildings or something. So to really get a representative sample, I think your clusters need to be as small as households. And so again, for cluster sampling, we divide into clusters. We take a sample of the clusters. So we're taking an SRS of households. And then within each household that gets sampled, we sample every person. Okay, so whether it's one person at a time, 5 people at a time, however many people are in that household, we get them all, and then we go to a different household. Okay? And we continue until 1,000 people have been sampled. This situation is one in which it would actually perhaps be easier if we had to get more people than 1,000. If we raise this up to like 100,000, we might be able to go to a whole city at once if the city only has like maybe 2,000 or 3,000 people in it. If we wanted to sample 1 million people, we could easily take cities, as long as we didn't get something like New York City or LA or something like that. Okay, but if our sample size is so small compared to a massive population, those clusters are going to have to be really small, or else you're going to be sampling almost everyone from the same cluster, and you don't want to be doing that. Because maybe people in Anderson are happier in general than people that live in Idaho, because there's nothing to do in Idaho. I apologize if anyone's from Idaho. I don't know. I've never been there. I assume there's not as much to do there. Anyway, so our last sampling technique is convenience sampling. Again, we don't really like talking about how to do this because it's not random in any way. It's not statistical. But how could you do a convenience sample of this? Well, there are lots of different ways. So you could stand outside a grocery store. You could just plop yourself right outside Walmart and ask people as they go by, hey, on a scale of 1 to 10, how happy are you? If you're there long enough, you'll get 1,000 responses. But is that a good representation of the United States? Probably not. It's a good representation of the people in Anderson who go to Walmart, I suppose. But that's not the United States. You could auto-dial random telephone numbers, as long as they're from the United States. That might be a better way of doing it, but it's still like, it's based on the people that want to respond. So it's not random in that sense. We don't really want to do it this way. We would want to stick to one of these. And none of these are particularly easy, but I would say that stratified and cluster are a lot more reasonable than SRS and systematic. There's no way you're going to be able to number the population in this example. So those are like super not going to happen. Stratified and cluster, you could theoretically do that. For stratified though, to take a simple random sample of 20 people from each state, you would have to have a list of all the people in each state. That's the only way to take a simple random sample. Cluster is the only option that's random and doesn't necessarily involve you having to know everyone that lives in the United States, which is a big help because you don't know. So I think cluster is really the most reasonable sampling method here. So I hope that by going through this example, you see one more time how each of these sampling methods work. So if you needed more practice, I hope that helped as you study up for your Chapter 1 test that's upcoming. Okay, so let's go back to the notes. And on the back side at the top of those notes, we have these 6 terms. And I got really used to sitting in this chair. I don't want to go back to the board and have to watch you write, or have you watch me write all these definitions at the board. So I figured this one time it might be easier to just reveal these definitions just like I did with the sampling techniques. We'll see how it goes. So each of these colors has 2 vocabulary terms with them, and those terms are naturally paired. So our first pair of terms here is census versus sample. And I've mentioned both of these words several times already in the class, but let's just make sure we know what each of these is. So a census is where information is collected on every element in the population. And I've already stated at least a few times, it's very difficult or impossible to get a census if your population is large. Even if it's relatively small. We've talked about Anderson High School students. To be able to get information on all of them, I'm sure that the administration in our school would love to have information on every single student that's enrolled. They can't even get all the information they need. So these are very, very difficult to conduct. The most famous census, and I'm biased because I worked at the Census Bureau, but it's the decennial census. Every 10 years we try and count everyone in the United States, and they're asked, 10 years ago they were asked 10 questions. Everyone in the United States was asked 10 questions so that we knew a little bit about who lived in this country. Just to do that took years of planning. It involved thousands of people working a lot of hours to design the census, to design the study itself. How would we get the census to everyone? What happens if they don't respond? Do we have to send people door to door? They do that. All that stuff. What happens if someone just doesn't respond? What do we do then? It's very difficult to make a census. So, in general, we're not going to know everything we need to say something about a population. Anything that is said about the United States or the people in the United States, no one took a census. I don't recall answering anyone's survey questions. Okay? What they did was take a sample. And a sample is when information is collected on just some elements in the population. Right? So maybe someone asked 1,000 people what they thought about something, and since they took a random sample from the United States, they generalized the results to the United States, even though not everyone responded. That's what usually happens. And obviously sampling, we know all the different methods, simple random sample, cluster, etc. So the reason this class is important is exactly because taking a census is so hard. But we still want to say stuff about the population. We want to say things about the United States as a whole, or Indiana as a whole, or Anderson High School as a whole. But we don't necessarily want to get everyone's responses, either because it's difficult, it's expensive, or it's impossible. So what we're learning in this class is how to take good samples and then how to analyze the data we get to say something meaningful about the population, even though we didn't get everyone. If we do a good enough job with our sample and our analyzation of our data, if we do a good enough job, then our results will hold up to scrutiny. They will be good and accurate. All right, so that's census versus sample. Next two terms here are observational study versus experiment. So an observational study is where data is collected from individuals in a way such that the relevant variables are unaffected. So this might be something like we take a bunch of overweight people. Say we take 100 overweight people and we observe their diets, their exercise routines, everything they do for 2 months. And we record their weight daily. Okay? All we're doing is observing what they're doing. We're not telling them what to do. They can do whatever they want. But we're recording data as it happens. We're observing what's going on from a distance. Whoever is analyzing that data has nothing to do with the subjects. They're not being told what to do. They're able to live their lives. So an observational study in that sense is passive. Data is being collected, but the individuals in the study aren't being told what to do. Okay, that's the main idea in observational study. Let's contrast an observational study with an experiment. An experiment is where treatments are given to groups of individuals in order to observe possible effects on relevant variables. So this is very different from an observational study. In that observational study, we're sitting back, we're letting life happen, and we're taking notes of what's going on. In an experiment, we're like, okay, you people do this, you people do this, and based on those treatments, based on what we're telling you to do, we're going to see if the treatments have an effect on something. So this might be like we take those 100 overweight people, we assign 50 of those people an experimental drug linked to weight loss. We think it might help people lose weight. The other 50 people get a placebo, which is the next term on the list, I know. But you might already know what a placebo is. It's not an experimental weight loss drug. It does nothing. Okay? So, by setting up this experiment, and we may tell them, hey, both groups, exercise this amount, eat this type of food, and then we can compare how much weight loss the experimental drug loss group experienced versus the placebo group. If there is a difference in how much weight those groups lost, then we can say that that's linked to the drug, and we can say the drug is effective. But the experiment needs treatments to be given. We need to be telling these people to do something. We are actively telling them what to do to see whether the treatment's effective. So these two things are very different. And it's all a matter of whether we're telling the individuals to do something, if we're imposing treatments on them, or if we're just letting them do whatever they would normally do and passively collecting data. Cool. So I mentioned a placebo in the experiment. One group got a placebo, whereas the other group got the experimental drug. So a placebo is something that does nothing, essentially. Specifically, it's where a subject receives no treatment. So maybe they take a pill, but the pill has no active ingredients. It doesn't do anything. But they don't know that. The group getting the placebo would not be getting told, hey, this pill is pointless, take it anyway. They're going to think that it's the experimental weight loss drug. So even though it does nothing, it's just a pill, it has nothing in it really, they can still lose as much weight as some people in the weight loss group, the people who got the real deal. So a placebo, they get no treatment, or the treatment does nothing, but they believe otherwise, resulting in a favorable response. This is called the placebo effect. And the human brain is not very well understood, even at this point in our civilization. We have no idea how the placebo effect works. If people think they're getting a weight loss drug, that's good enough sometimes for some people to make it work, even if it's nothing. I think of the movie Space Jam. If anyone's seen Space Jam, at the end of the movie, the Toon Squad is losing to the Monstars. So Michael Jordan's like, oh man, I got this secret stuff. I put it in this bottle, like this liquid, and if you drink it, you'll become like an amazing basketball player, and that'll be enough to defeat the Monstars, right? And so every Looney Tunes character is like, oh man, give me that secret stuff, and they're all drinking it, and they're all like hulking out and being cartoony and amazing. It's just water. And Michael Jordan knows that, but the Looney Tunes don't. And even though it's just water, it has the intended effect. They become confident. They become better at basketball, and spoilers from a movie from 20 years ago, they win the game, right? So the placebo effect is an amazing thing, and it's effective in treatments because you don't want the people knowing that they're getting the placebo. That would ruin the whole point of the experiment. So, not telling the subjects what treatment they're getting is important because we don't want that to bias the results, right? That's called blinding the subjects. The subjects are blind if they don't know what treatment they're getting. So that would be a blind study or a blind experiment. A double-blind study or experiment, you might be able to parse out two groups of people don't know what treatments are being given to whom. The subjects don't know, but someone else doesn't either. And it turns out, for a double-blind study, neither the subject nor the treatment administrator, whoever's giving the treatments, doesn't know who's getting what. The most common type of study that I see this is in drug trials, right? We're saying that the subjects themselves don't know whether they're getting the real experimental drug or a placebo. But if the study is double-blind, not only do the subjects not know, but the doctor giving them the drugs doesn't know which group is which. They're just given the pills. Someone knows if those are the real pills or not, but not the doctor. Why don't we want the doctor to know? Because the doctor could subconsciously, if he or she knows that a treatment is the real deal or the placebo, they might subconsciously act differently. Like if someone's getting the drug, they might kind of coach them towards things that will make them lose more weight. Who knows, right? If they're getting the placebo, they might be like, here, take this. It doesn't really matter, whatever. It's just a placebo. Like they wouldn't say that, but they might act that way. And that could influence the results. It could mean that a difference in weight loss in the two groups could be because of the doctor and not because the drug is effective. And we don't want that. We want to eliminate any sources of bias that we have. So we blind the doctor as well as the subjects. And that's like the gold standard for an experiment, is to have as few people know as possible who's getting what. So again, I'm not a huge fan of spewing vocabulary at you all. I don't feel like that's an effective method of teaching, but there's just no way around it. You have to know what these terms mean. And I tried to put a little bit of a story to them so that you've got something to attach it to. You do have to know these terms. Okay, not word for word. I'm not going to make you vomit the definition back at me, but you have to understand the concepts. That's what's important here. So, in the notes, you've got one last little thing, and it says potential pitfalls of a survey. And that'll be its own video for the next e-learning day, probably tomorrow if this isn't Friday. And that'll be a relatively short video, I think, and hopefully it's enjoyable. It's going to be another PowerPoint with slides, but I've got a whole bunch of ways things can go wrong in a survey, and I've attached stories to each of them. And so I will tell you the story, and you will try and find out what's wrong with the survey or the study. And hopefully it's fun. I think it'll be enjoyable. So this video has gone on long enough, so we'll end it here. So until next time, have a great day, and we'll see you.